Hello from FTC 2024, where I'm talking to Andrew Gascoyne from the University of Wolverhampton. Hi, Andrew. Nice to have you here.
Yeah, thanks for having me.
So you're not presenting a paper yourself. You are here supporting your PhD student who is.
That's right, yes, and I'm a co-author along with some team members up at University of Wolverhampton as well, yeah.
Okay, and what's the research about?
So it's about chaotic neural networks as an application to solve optimization problems. So sounds quite exotic compared to some of your standard type neural network type problems, but that's what we're looking into.
How can you explain that or simplify that for someone like me?
Sure. So the principle of chaos is that small changes in initial conditions can create large differences in future behaviors.
Butterfly effect.
Exactly. That's where that comes from. And so we're essentially we're creating neural network models where the neurons themselves exhibit chaotic behavior. But it's transient chaos, so that chaos hopefully will die down after a time and then stabilize. And it's a way of, looking for solutions in, these landscapes, solution landscapes and things like that.
Okay, so if I get my head around it, complicated stuff. What are the practical applications for this?
Yeah, so traditionally, these types of networks, they go back to Hopfield type networks, which is kind of like just a basic gradient descent, but they're often used on like location allocation type problems. Again, the classic is like the traveling salesman type problem, where you've got cities and you want to, visit every city and what's the most efficient route to take type thing. So you can use these type of networks to solve those types of problems. So often in telecommunications these days is a location allocation problem, effectively.
Okay. And does that have benefits for sustainability, for example?
Well, exactly. I mean, it's one of the reasons we've been looking into these architectures because they are very low intensive in terms of energy consumption. They don't require a lot of data to train, things like this. So labeled data is often difficult to come by. So these networks have that kind of advantage, but they have some disadvantages as well, obviously, which is why they're not being used as much as, let's say, it's contemporary other techniques and stuff.
Okay, so complex stuff.
Yeah.
What kind of challenges have you had with your research?
Yeah, so with these networks, they're mathematically a bit more complex than your traditional methods. So it involves kind of these iterative algorithms. They're based on differential equations. I do have a maths background, so I understand it a little bit. And obviously, we're trying to control chaos, which obviously in itself is a difficult minefield to kind of navigate as well. But yeah, so they're the difficulties. It's like I say, they're not huge networks. They're small, but they're complicated in how they behave, if that makes sense.
Were you pleased with your PhD student's presentation?
I was very pleased. Excellent. She's a very good speaker, Emily, my student, and yeah, she did a great job on the project. And she's been doing some funny videos at the conference as well. So I would have a shout out about those ones.
I've seen them. They're great. They're great. I love her videos. So I'm going to ask you a few rapid fire questions.
Sure.
That's all right with you. Okay, which industry do you think will be most transformed by AI in the next 5 years?
Well, at the moment, in terms of my work, we're liaising a lot with wildlife conservation and things like this because the global north-south divide in terms of technology infrastructure and things like this. It's very difficult to run some of these large language models, which require lots of resources, cloud infrastructure. They're expensive. So we're working with a lot of kind of environmental organizations and things like that do monitoring of, species and things like this in areas, as you can imagine, that don't have a lot of infrastructure. And you can use like these lightweight models as kind of as part of edge processing devices, which is essentially in the field on the device itself.
Yeah.
That makes
So
sense.
field of constellation,
Yeah.
AI will have a huge impact.
I think that is going to be, it's one of the areas that isn't being looked at, I would say is not quite there yet because there's lots of applications in industry already.
Yeah.
I mean, I was at a conference a couple of weeks ago with the IBM user group in the UK, and yeah, they're developing chatbots based on their manuals in their business and things like that, to help their employees and customers and all this kind of stuff. So it's transforming industry, I would say, already, kind of thing. So I would say that's going to continue over time anyway.
Right.
But yeah.
So another AI question. Do you think machines can ever become truly creative?
Creative, right. So, that term needs defining very carefully, I would say. Now, it's funny you should say that, because the models we use, because there's chaos involved, that's linked to unpredictability in how the system behaves. So it does throw up kind of unique things that aren't based on the data it was given, kind of thing. You see what I mean? So there is possibility of, I would say, more authentic creativity, as opposed to, okay, this is all the data it's been trained on, and effectively what it's doing is, packaging that, maybe, messing around with it a little bit, and then presenting that to your audience, kind of thing.
So we'll see what after philosophical discussion about what is creativity. Is it coming out with a very random thing?
Yes, exactly.
Nice. Okay. Another quick fire question. Privacy or innovation? What's more important for you?
Oh, for me, innovation, for sure. Obviously privacy is very important, but I don't step into that realm very often. What I'm dealing with is models and, mathematical models, or, these neural network architectures, playing around really. It's like a Lego toolbox I'm playing around with. The privacy issues are quite minimal, as you can expect, and the ethical considerations are all similar.
So tinkering around ways.
Well, exactly. Yeah. Exactly.
Which country do you think is leading the way with AI right now?
That's a good question. I mean, America, obviously, that's where the noise is coming from. The large, computing companies, Google and their related AI, companies involved, Microsoft and things like that. So it is coming from America, I would say, in terms of those large AI models and things like that, and the applications. But, there's opportunities for elsewhere, to start creating or utilizing these things, and you can actually start building your own AI models. It's amazing. You don't have to be a programmer anymore to start using these things. It's quite incredible. The software's there. You just use the platform and off you go, kind of thing. It's so
make it sound so easy.
Well, in many ways it is. It's just it's very new. It's just being willing to Previously, it was like Excel, I guess, was difficult. Oh, I'm not using Excel, but everyone's using Excel now in companies. And it's kind of similar, really. It's a platform like Excel, and you can just start pointing and clicking and kind of build your own models and apply them.
I might have a go.
Yeah, do.
Won't end well. So, is this your first time at FTC?
It is.
Okay. How are you liking it?
Oh, it's great. Brilliant. I've really enjoyed it. I've been talking to a lot of people since I've been here. Like, one of the main things I've been trying to, one of the goals coming to this conference was, finding other applications, especially for the models we're developing, because, a lot of the noise is around these large language models, and we know we can do applications that, we can't do what they do, but we can do kind of smaller projects, and finding those applications, it's been really helpful since I've been here.
Oh, yeah. You've been inspired.
Exactly, yeah. And I've been talking to people, and we're going to, carry on the conversation, as it were, and see if we can help. Can our models help their discipline? That would be great.
Great. That might do some future collaborations.
Exactly, absolutely.
Brilliant. Any other, apart from your own student, any other papers, presentations that really struck a chord with you?
So actually, I would say I think it was yesterday afternoon in the Hogarth suite. There was a talk on like linearizing some of the language models, and therefore reducing them down, and then you can have a snapshot and kind of simulate, and therefore have kind of a lightweight model developed, because this is your test case. It's actually over here. You don't need to take the entire data set. It's like, well, actually, we're looking at this. And that was a really interesting talk, actually, how to reduce complexity within these very complex systems, kind of thing. So that was really good.
Any other topics you'd like to see added to future conferences?
Maybe like a climate, or a green computing, green energy, green technologies type thing, applications in that would be good to see.
Okay.
A shout out as well to the e-learning. I think that was the morning session yesterday as well. That was great as well, because I'm involved in some maths education type projects as well. So that's always good to see.
Well, it's been nice having you here, Andrew. And will you be joining us next year in Munich?
I suspect so. Yeah, certainly. Yeah, so I'll be looking out for the new call, and submit and see how we go.
Hope so.
See you. Yes. All right, great. Thanks.